Brave House. Oh, today we're going to have a blast. You're going to learn something brand new. You're going to learn exponential functions. You're going to learn what the graph of an exponential function looks like. What's an exponential function, you say? Oh, well, we're about to find out. Remember, in the fall, you did linear functions, which graph to line. When we came back from Christmas, we studied quadratic functions. And quadratic functions graph to curve called a parabola. Now we're going to graph exponential functions, which will graph an exponential curve. We're going to have F-U-N, fun, fun, fun. So a magical whiteboard appears, and let's start talking about exponential functions. Okay, really quickly, right off the bat, the first thing you see is the form of the exponential function, okay? Y equals AB to the x. Notice the x is in an exponent in it. That makes this an exponential function. This will not have a constant rate of change. It's going to exponentially grow because the number you're plugging in is in an exponent. Also notice that this a right here is equal to the y-intercept. That's where you're going to start your graph at, okay? It's kind of like the starting number or the initial amount. And the b is your growth or decay, and it's going to be called your common product. That's what you multiply to get to the next number, okay? So we're going to have y equals ab to the x. In Algebra 2, you'll add a constant to this, okay? In Algebra 1, we're just going to keep it y equal ab to the x. Now then, let's look at what happens when we graph this. Let's graph y equals 2 to the x. And just do that on your calculator. So if we do that on the calculator, we're going to go to graph b. And then just type in 2, hit the up button for caret, or for your exponent, then x. So y equals 2 to the x, okay? Hit enter. And notice we have this graph, don't we, okay? Now then, let's go back to the paper. If you have y equal 2 to the x, it's really y equal 1 times 2 to the x. The 1 is your y-intercept, and the 2 is called the common product. Now then, let's look at the table of this. So I'm going to hit Control-T to get the table. And if you look at the table, the numbers in the y's are all getting multiplied by 2, right? So if you go down, the x's increased by 1, but the y's are getting doubled. That's because our common product's 2. Let's go to the 0 amount. Okay, so if we go to the 0 amount, right here, the 0 was 1, right? Which is the y-intercept. Notice also what happens to your y's as you go up. As you go up, they're not getting multiplied by 2, they're getting multiplied by a half, or they're decreasing by a half, right? So if you go down, you multiply by 2. If you go up, you multiply by the reciprocal of 2, which is 1/2. Okay, so that's huge in this, okay? So as we go to the right, the numbers are getting doubled. As you go to the left, they're getting smaller by a half. Also notice we go up this, no matter how we go up, the decimal keeps getting smaller and smaller and smaller, but it will never, ever, ever reach 0, or it will never go negative. That means it's going to get really close to 0, but never, ever cross it. So let's go back to our paper. This line right here, the x-axis, is very important. That's the line the graph goes to, but never, ever approaches it. Now then, let's graph this one. Y equals to the 1/2 x, and we're going to use 0.5 for 1/2. Okay? So let's go to here. I'm going to hit Control-T to get out of the table. Hit delete, delete, delete. Hit enter. And then we're going to type in tab to get another equation. Then 0.5, which is 1/2, caret for the exponent x. So I have 1/2 to the x power, hit enter. Notice the curve is kind of flipped in it. The curve's not going up, the curve's going down, but it still approaches the x-axis in it. It's never ever going to cross the x-axis. Now let's hit Control-T. Did I hit Control-T? I hit Control, let me hit Control-T. So Control-T, notice that as you go down, it's the opposite of y equal 2 to the x, right? The numbers keep getting smaller. If I go up, the numbers keep getting bigger, don't they? So this is just the opposite of this. This is not growth, it's called what's called decay, okay? So those are two examples of this. Also remember that the x-axis is the line that graph goes to but never crosses, okay? The x-axis, which is y equals 0, is called a horizontal asymptote. That is a new word you've never heard of before. An asymptote is a line that it approaches but never crosses, okay? So it's a line the graph approaches but never ever crosses. Almost all the graphs we do in Algebra 1, the x-axis will be the horizontal asymptote. Now then, if you go to the next one, okay, using the exponential graphs functions below, determine whether the graph represents exponential growth or decay. Also state the horizontal asymptote. So we're going to write down growth or decay in the horizontal asymptote. On this one, the graph is going up. That is growth, okay? Now then, if I draw a line at where the graph goes to, it's going right through here, which is y equals -2. On this one, the x-axis is not the asymptote, is it? So we just got to figure out where the asymptote is. On this one, okay, the graph is going down in it. That is called decay. Now then, draw a line where the graph goes to. It goes to right here, doesn't it? It crosses right there at 1, doesn't it? So the asymptote is always horizontal, so it's going to be y equals 1. Most of the time, the asymptote will be the x-axis or y equals 0, okay? See if you could do the next two on your own. Okay, evaluating an exponential function. Suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population will double each week. Insect population, a lot of animal population grows exponentially until they can't sustain itself with the food supply, then it'll plateau. Same thing with the virus that shut us down last year. The virus grew exponentially. It kept on going until there's no more people to affect. So what they did is they shut the economy down. They told everyone to stay home so it wouldn't go up so high, so it would flatten off, so the hospitals wouldn't be overrun, which is what's called flattening the curve, okay? That's exponential functions right there. That was all exponential functions. So let's look at this. The function y equals 30 times 2 to the x gives the population. So let's write this down. F of x equals 30 times, and I usually put that next number in parentheses. This right here is the initial amount, or the starting number, or the y-intercept, and this is your common product, or the growing amount, okay? It's what your population's going to do, okay? Now then, we want to know after 56 days. 56 days divided by 7 is 8 weeks. So you're going to do 30 times 2 to the 8th power. So punch that into the calculator. So let's go to the calculator. I'm going to hit Control-T to get rid of the table. Then I'm just going to hit Home and Calculate to go to the scratch pad. And then I'm going to put 30, parentheses 2, close parentheses, caret 8. So this is going to give me the population after 8 weeks. And it's going to be a big number. 7,680 beetles, okay? So 7,680. And it's just going to keep doubling, like I said, until the food supply can't support the population. Let's go to another one. Okay, on this one right here, the 20 would be the y-intercept. So we would start at 20, but this would be decay, wouldn't it? Because it's less than 1. If your common product is smaller than 1, the number's going to get smaller, okay? So we want to solve this for x equals 3, so we're going to do y equals 20, put the 0.5 in parentheses, and 3. Type that into the calculator. So 20, parentheses, 0.5, close parentheses, caret. Ooh, I forgot to do this. Close parentheses, caret, and then 3, right? Did I do that right? Yep. So hit enter. Now then, I'm going to do this in my brain. We're going to divide by 2 3 times. So half of 20 is 10, half of 10 is 5, and half of 5 is 2.5. We're going to do a half 3 times, aren't we? The answer should be 2.5. Let's see if it is. And it is 2.5, okay? So if you take 20 and take half of it 3 times, which is what the function's saying, you're going to get 2.5. So this would equal to 2.5 or 2 5/10 or 2 1/2. Could also be 5 over 2. Let's go to the next one. An investment of $5,000 doubles every decade. Oh, that's good money. Okay? So this right here is the function. So let's write down f of x equals 5,000 times 2 to the x. Remember, this is the additional amount. That's also going to be the y-intercept, right? And this is the common product. Kind of like what we did in geometric series, right? Now then, we want to find out after 30 years. So a decade is 10 years, so 30 divided by 10 is 3. So we're going to do 5,000 times 2 to the third power. Let's see if we can do this in our brain. We're going to double 5,000 3 times, aren't we? So if I take 5,000 and double it, I get 10,000. If I double 10,000, I get 20,000. If I double 20,000, I get 40,000. That's more money for the government to tax you with. Isn't that cool? But anyway, 5,000 times 2 to the third should be 40,000. Let's see. So 5,000, parentheses 2, close parentheses, caret 3, enter, and we get the 40,000. So we took 5,000, doubled it 3 times, boom, 40,000. So this is going to give us 40,000 bucks. Oh. Continuing on, okay. Fun. Okay, on this one right here, we have 2 times 0.4 to the negative 2. Okay, so the 2 would be the y-intercept. The 0.4 means if I go to the right, the number's going to get smaller, but I'm going to go back to the left. I'm going to go on the other side of the y-axis. Okay, so I'm going to punch you straight into the calculator. My answer should be more than 2, shouldn't it? Because I'm going backwards, okay? So 2 times 0.4 to the negative 2, 2, parentheses, 0.4, close parentheses, caret negative 2. Okay, hit enter, and I get the 12 5/10. So my number's getting bigger in it because I'm going to the left instead of to the right. So this will be 12 5/10. This unit is going to be very simple. It's a lot easier than what we did with quadratics. Solving those quadratics by factoring is the hardest thing you do in Algebra 1, okay? Very difficult to do. Now that you're going to do these on your own, I'm going to do 1 with you, or 2 with you actually, then I'm going to let you do the others. So there's 6 graphs to do. So the way I want you to do this is write down, okay, this is state whether each is growth or decay, graph it, and then find the domain and range. So we're going to do that for each one. So right off the bat, write down the y-intercept equals 4. So this graph is going to cross the y-axis at 4, and this is the common product. Notice that it's less than 1, right? So if I multiply, the number won't get bigger, it'll get smaller. This will be decay. Now then, make a t-chart on all of these, put x and y, and go from negative 2 to positive 2. Okay, that's going to give you the points to graph, and then you can graph it, okay? And then we're going to write down the domain and the range. Got it? Okay, so let's go to the calculator. We're going to go to graph. So home and graph. We're going to hit delete to get this graph off. And then I'm going to graph 4 times 0.5 to the x. So I'm going to graph, hit tab, 4, parentheses. Now then, if you had 1/3, you would need to put control divided, put the 1/3 in there. I'm just going to switch the 1/2 to 0.5. You could also hit control divide and put 1/2 in there. Just less punches on the calculator. Caret x. And then I'm going to hit enter. Now then, I want my, remember this should cross the y-axis at 4, and its exponential decay goes down, and the asymptote is the x-axis in it. Okay? So let's hit control T. And remember, our table needs to go from negative 2 to positive 2. So boom, that's my table right there. So notice it's at negative 216, and then the y's just divide by 2, don't they? You're multiplying them by a half. They're getting smaller. That's why it's decay. So I'm going to copy this chart down. So 16, 8, 4, 2, 1, and this right here is the y-intercept, which is this number, right? Okay. So it's going to then graph these dots. Remember, as you go right, it doubles. So I'm going to get this. So the graph will look like this, won't it? Okay. Now then, the domain on all of these problems will be all real numbers. Okay. The range is going to go from here up, right? It never gets to 0 though, does it? So the range is going to be y greater than, not equals, just greater than to 0. And one more thing, let's write down the asymptote so you remember this. The asymptote will be the x-axis, and just write y equals 0. Every single time you write the asymptote, it's going to be y equal a number. On these graphs, it's always going to be y equal 1/2, or I mean y equals 0, which will be the x-axis. Now then, I'm going to do a growth. So let's do number 3. Number 3 is going to be kind of tricky because there's going to be a lot of fractions in there, okay, and decimals, okay? So this one right here, this is our y-intercept, which means it's going to cross at a third, which is like right here in it. This right here is our common product, and I'm just going to put CP period. Okay, let me do this. C period, P period, right? The common product. Since it's more than 1, this is going to have growth. So this curve is going to go up in it. This curve will go up. Write down the x and y, put a t-chart for every one, and go from -2 to +2. Then we're going to get the domain and range, and then we're going to write down the asymptote. Do that on every single problem. So let's go to the calculator. 1/3 times 7 to the x. Okay, so I'm going to hit Control T. This is going to have some big decimals in it. Delete, delete, delete. Think of a bad thought when you do that. Tab. And now that I'm going to hit Control Divide to get my fraction in there. Do not change 1/3 to 0.3 because it's not 0.3. Don't do that. Ugh. Do 1 down 3. You can't even change it to 0.33. It won't work. Go over here and then parentheses. And we had 7. Yeah, 7. So 7. This is going to get bigger quicker. And then x to the x power. Okay, so this is going to cross the y-axis at 1/3 and quickly go straight up, okay? Because the common product is 7. You're going to be multiplying every time by 7. And there's going to be a lot of decimals in here because 1/3 is 0.3333, okay? Notice that the asymptote is still the y-axis, right? Your asymptote will almost always be the y-axis unless you have a picture where it's shifted up or down, okay? Now then, let's hit Control T, and remember, we're going to go from -2 to +2. So Control T, and now that I'm going to go up. Notice there's a lot of decimals, and let's round these to the 10th, okay? So I'm just going to go up. I'm not going to make y'all write these as fractions. And we need to go from -2 to +2, right? Need to go back up, get the table where I want it. Okay, we're right here. Okay, so -2. Let's just go to 0.007. Okay, so 0.007. And then 0.047. 0.047. Let's just go to the thousandths place. 0.333, which is the 1/3, right? And then if I go 1, it's 2.333. 2.333. Then hit again, 16.333. 16.333. Okay, so I just wrote down 3 decimal places, okay? Now that I'm going to graph those, notice that it's going to be really close to 0. Then it's going to quickly go up. 1 is at 2.33, and then 2 is up here at 16.33, right? So the graph does something like this, right? It goes straight up, doesn't it? That's because our common product, 7, is going to skyrocket real quick, okay? So the domain, remember, we could go left or right as much as we want to. So the domain's going to be all real numbers. The range is going to be y greater than or equal to 0. It's going to repeat every single time. The asymptote is y equal to 0, which is the x-axis. Okay? All you have left to do is 4 more graphs. You need your calculator. If you got decimals, go 3 decimal places. Just drop the decimal. Don't worry about it being that accurate. The star, they may use fractions, okay? Which is fine. Finish these up. You're going to have a blast doing this. The word problems involved with this are pretty cool because you're dealing with exponential growth or decay. Have a wonderful, wonderful day. Thank you so much for watching me today. Have a wonderful day. Remember, you are amazing. You are created to do wonderful things. And you are awesome.